Hey, what's up, guys? I'm going to show you how to prove that a quadrilateral is a rectangle on a coordinate plane. This is coordinate proofs. If you haven't seen already how to prove that a quadrilateral is a parallelogram, click that link that I'm going to leave and check out that video first, because you need to know that before we do this. All right, let's start. So I'm going to draw you that parallelogram tree. And as I said, you need to know how to prove something is a parallelogram. And the easiest way to do that, just as a quick recap, now there's more than one way, but the method that I'm going to use is to show that opposite, I'm going to just leave OPP, hey, you know me, show that opposite sides are parallel, right? And we could do that by using slopes. If opposite sides have the same slope, then they are parallel. Okay, so this is just a general parallelogram. Okay, now here's what you need to know. I'm drawing this little tree. I'm gonna leave this side blank, but I'm just gonna let you know that this over here is a rhombus, and that will be in another video. But that is a parallelogram, and alongside that we have a rectangle, which is also a parallelogram. Now, the special things that you need to know about a rectangle is that not only is it a parallelogram, but it's a little bit special because adjacent sides, now adjacent means two of the lines next to each other, two of the sides, adjacent sides are perpendicular, which means it forms a right angle. And since opposite sides are parallel, you could expect that right angle to happen at every single corner. I'm only going to draw one. So that's one important property of a rectangle. I'm just going to write that down. Adjacent sides are perpendicular. Now, here's something that you may not know about a rectangle. Like the right angles you might have known since middle school, but the new thing that you probably wouldn't know is that the diagonals, now a diagonal is a line that connects opposite vertices. Vertices are just the corners. The two diagonals, every quadrilateral has two diagonals. The two diagonals are actually the same length. It's a very important property. Diagonals of a I'm sorry, why did I write that? I'm not even gonna write all that. Diagonals are, now when you want to say something's the same length, you could just say that they are congruent. When you're using numbers, you say equal. When you're talking about parts of something, we use congruent, meaning that they're the same. And that's a little symbol for congruent. Oh, and the upside down T is really two lines forming a right angle, which means perpendicular. All right, and let me pull up my red pen, because I just want to show you that to show that two sides are perpendicular, you simply show that they have negative reciprocal slopes. All right, and definitely check out the other videos in the series to know how to show that two lines are perpendicular. And to show that two things are congruent, you could either use the Pythagorean theorem if you have it on graph paper, or if you prefer, you could just use the distance formula. Just gonna leave distance formula right here. That's a U. All right, so these are the two things. You first, to prove something is a rectangle, you must prove that it is a parallelogram. I'm going to put this in a cloud to make you happy. And after you do that, you have to prove one of these. You don't have to show both of them at the same time. you could just show only one is necessary. If one is true, it implies it's a rectangle. It implies the other one is also true. Okay, and rhombus, we'll check again. So let's check out a video, shall we? A problem. All right. So here we have quadrilateral ABCD, and I'm going to plot those points. So starting at the origin, I'm going to go back 6, 1, 2, 3, 4, 5, 6, and then up 2. I'm going to label it right away. And B is negative 3, 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6. This is a little bit tiny on my end. It looks good on the screen, but let's see. C is 9, negative 3. So that's 8, 9. 1, 2, negative 3 is right there. Notice how I'm labeling it as I plot it. You don't want to wait. Otherwise, you could lose track of which point is which. And D is 6, negative 7. That's right here. Just gonna connect those just by hand, not using a ruler or anything like that. Now, to show it's a rectangle, remember what we first said. We must first show that it's a parallelogram. And how do you show that a quadrilateral is a parallelogram? Find the slope of all the sides and just show that opposite sides have the same slope. Therefore, it's parallel. So what are the four sides of the shape? We have AB, BC, CD, and AD. So it's up to you which method you want to use to actually find the slope. Some folks will want to use the formula. I'm going to just write that down. y2 minus y1 over x2 minus x1. And let's actually do that for AB. So I'm going to just circle the points. That's A. This is B. Let one of your points be a 1 and the other one be a 2. And of course, every point has an X and a Y. So my Y2 is actually going to be this 6 over here. My Y1 is going to be this one over here. So it's 6 minus 2 over. And my X2 is going to be that negative 3 minus... So this is important here. Minus a negative 6. So notice it's minusing a negative. You have two minus signs there. One way to think about two minus signs is just by adding. It's like a plus. I'm not going to get into the math behind that. Just, that's just a shortcut you could use. So 6 minus 2 is 4. Negative 3 plus 6 is positive 3. So that's the slope of that line, 4 over 3. For the slope of BC, I should label these slopes. Okay, so for BC, I'm going to use red, and I'm just going to count this one because I just want to show you that you could actually just use a graph, right? No need to use the y2 minus y1. If you weren't graphing it, that's the best time to use the formula. If you are graphing it, then by all means, just count it. So I'm going to make like this. You got to follow the lines of the graph paper, make this little right triangle to see a rise and run. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went up 9, and I'm going to go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went back 12. So it's a rise over run. So it's 9 over negative 12. Simplify that, divide both numbers by 3. And I get negative 3 over 4. Put the negative with the whole fraction. And yeah, so there is the slope of BC. Now, I know that AB and CD, I know that they're going to be parallel because we're proving a rectangle. You could do the work. I'm not. CD, I know must have the same slope as AB. I'm kind of cheating a little bit. Don't do that though. You don't do that. You actually check it. But CD, I know is going to have a slope of 4 over 3. And what slope do you think AD is going to have? Yeah, opposite sides must be parallel. It has to have the same slope as BC. Negative 3 over 4, right? BC and AD are parallel. They must have the same slopes. Okay, so this is pretty much it. Let's just write a statement. Oh no! What just happened? Okay. No, oh, no. What? Why? Why is it doing this? Okay. Okay. We're good. We're good. We're good. That's so finicky. Okay. Let's just finish this up by writing our statement. So, quadrilateral, ABCD is a parallelogram. Remember what I said, you have to prove it's a parallelogram first. Is a parallelogram. Why? Gotta give a reason. Because opposite sides are parallel. Just gonna use a symbol. And how were we able to tell they were parallel? Opposite sides had the same slope. Okay, so that's statement number 1. Right, you have to say it's a parallelogram. After we have declared that this shape is a parallelogram, now we could go down that parallelogram tree. What kind of parallelogram is it? Well, I could tell that these sides over here are negative reciprocal slopes, right? One is 4 over 3, the other one is flipped, and the sign change. So that's what we call negative reciprocal. So that means that those two sides are perpendicular. And what do we know about perpendicular lines? They form right angles. So basically, this shape has a right angle in it, and that just makes it a rectangle. So now I'm going to call it parallelogram. Parallelogram. ABCD is a rect. I'm just going to write rect because I'm kind of running out of room there. It's a rectangle because adjacent sides are perpendicular. You got to put the word "are" in there, but I kind of just wanted to fit in here. Adjacent sides are perpendicular. Done. All right, so let's just kind of recap it real quick. You plot your shape. You don't even have to because you have formulas to show this. Find the 4 slopes of the 4 sides. And after you do that, show that opposite sides have the same slope. Therefore, it's parallel. Therefore, it's a parallelogram. And then show that adjacent sides have negative reciprocal slopes. Therefore, those sides are perpendicular, meaning it forms a right angle, meaning it's a rectangle. There is one other way. I'm just going to go back to that first thing that we did. So we used this one because it was like less work. But you could have used diagonals are congruent to each other. So here's what we could have done. All right, so I'm going to erase this. I'm going to erase this thing. Parallelogram ABCD is a rectangle because let me use a different color. Because the diagonals are congruent. However, you need to support this though. Like, you said something, where's the evidence of it? Right? You got to back it up. So that means you'll actually have to find the length. So I'm going to just like kind of like put that like that. You're going to have to find the length of the 2 diagonals. So what are the diagonals? AC and the other one is BD. I'm just going to use the distance formula. Whoops. I'm going to do it for BD. Like, I know they're going to be the same, right? So I'm only going to do it for one side, but if you're showing this, you have to show it for both sides as proof. But I'm just going to show one side. So the formula is x2 minus x1 plus y2 minus y1. I'm going to erase this now because now I'm going to change the two sides that I'm going to use. I'm using B, which is this one, and D, which is that one. X2 minus x1. I could do the y's first, but anyway, x2 minus x1. So I'm going to call this one my 2, and I'm going to call this one my 1. So x2 is 6 minus x1 is negative 3. So remember what happens when you have two minuses together. You could think about it like it's a plus. And the other one is negative 7. Because I started with 2, right? It must be x2 or y2 minus y1 minus 6. And don't forget a little square. And I always like to put this little thing here to like close off that square root. And just gonna kind of continue to work up here. I notice I'm doing this piece by piece. 6, this is like a plus because minus and minus is like a plus. 6 plus 3 is 9. What's 9 squared? 81. What is negative 7 minus 6? That is negative 13. What's negative 13 squared? I think that's just 169. You could add those together. 9, 10. Carry the 1. 8, 9, 10, 15. Carry the 1. Is it 250? Is my math right there? Whatever the case. I'm not even going to simplify this right now. All you have to do is say that this thing is whatever length it is. And then you do the same work for AC, but using those 2 points. Somehow show that it's the same length. So you could now use this reason. Now you have the privilege of using that reason. All right, so I just showed you 2 ways on how to show that a rectangle is how to show that a quadrilateral is a rectangle. I hope this was informational. And this video is a little bit long. I'm trying to see the time. I don't have a time I can't see how long I've been recording for, but this video is long. I hope it was useful. I'm actually just going to move, so like if you want to screenshot that, you can screenshot that. There it is. There it is. And I'll leave you with the example to try. Good luck. If you thought that I left something out, or you think somehow I can have made this better, just let me know. All right. Peace.